Hello everyone. This video is about solving of trigonometric equations. So what are trigonometric equations? These are equations that involve trigonometric functions. So these are equations that they involve sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. An example of a trigonometric equation is sine of the angle A minus 1 is equal to 0. So the goal here is to solve for the angle or angles A that will satisfy this particular equation. Now, trigonometric equations have infinitely many solutions because of the property that trigonometric functions are periodic. But in our case, in our discussion in this video, we shall only consider solutions from 0 or from the angle 0 up to the angle 2 pi. The solutions of the equation sine A minus 1 equals 0 are A is equal to pi over 2, 5 pi over 2, 9 pi over 2, and so on and so forth. However, between or from 0 up to 2 pi, the only solution is angle A is equal to pi over 2. Now we do that by transposing the negative 1 to the right side, and we get sine A is equal to 1. So the only angle that will satisfy this equation is pi over 2 from the angle 0 up to the angle 2 pi. Now, there are several techniques in solving for trigonometric equations. So the first technique is whenever the trigonometric equation contains a single trigonometric function. An example of this is the equation in the previous slide. Sine A minus 1 equals 0 is an equation involving only a single trigonometric function, which is in this case sine A. So if ever the trigonometric equation has a single trigonometric function, we separate that trigonometric function and then the rest at the other side of the equation, and we find the values of the angles. Second technique is we can make use of the square root property. So that means the trigonometric equation may be written in the form of x squared equals a constant. So in this case, we can use the square root property by writing x is equal to positive negative square root of a. So the third technique is some equations may be in quadratic form. So that means the trigonometric equation may be converted into a quadratic equation, and we can solve that by using either factoring or the quadratic formula. Now, the fourth technique is some equations may be solved using trigonometric identities. So you have to make sure that you remember the basic identities, the ratio identities, the reciprocal identities, the sum of squares identities, and sometimes it will require recalling the double angle and the half angle identities. So let's start off with this particular equation. Let's try to solve for 3 sine A is equal to the square root of 3 plus sine A. Observe that this equation contains only a single trigonometric function, which is sine A. So in this case, we shall separate that trigonometric function on one side of the equation, and then the rest of the terms should be at the other side. So we start with transposing positive sine A from right side to left side. So this gives us 3 times sine A minus sine A is equal to square root of 3. Now, at the left side, now we can combine 3 sine A minus sine A, which is 2 sine A, and it is equal to the square root of 3. And then we divide both sides by 2, and this gives us sine A is equal to square root of 3 over 2. So our goal is to determine the angles from 0 to 2 pi that will satisfy this particular equation. Now observe that sine A is equal to positive square root of 3 over 2. And sine, the trigonometric function sine, is positive in quadrants 1 and quadrant 2. So in this case, sine is equal to square root of 3 over 2 if the angle is pi over 3. So if we use the angle pi over 3, the y-coordinate of the terminal point of pi over 3 is square root of 3 over 2, which is equal to the sine function. Now, given the terminal points on the unit circle. So this means that in quadrant 1, the value of A is pi over 3, while in quadrant 2, the value of A is 2 pi over 3. Therefore, the solutions of this equation are pi over 3 and 2 pi over 3. Next, let's try to solve for 4 cosine square A minus 1 is equal to 0. So again, this equation contains only a single trigonometric function, which is cosine of A. Now, since cosine is squared, we can take a look at using the square root property by separating cosine square A on one side of the equation and the rest at the other side of the equation. So first, we will transpose negative 1 from left side to right side. And this gives us 4 times cosine square A is equal to positive 1. And then we can divide both sides of this equation by 4. And we get cosine square A is equal to 1/4. Now, observe that we have something that is squared on the left side equals a constant on the right side. And in this case, we can make use of the square root property by writing cosine A is equal to positive negative square root of 1/4. But square root of 1/4 is equal to 1/2. So this gives us cosine A is equal to positive negative 1/2. So this equation will result into two cases. The first one is when cosine A is equal to positive 1/2, and the second one is when cosine A is equal to negative 1/2. Now, cosine is 1/2 whenever we use the angle pi over 3. So cosine A equals 1/2. This is positive. So therefore, in this case, the angle A must be in quadrant 1 and quadrant 4. While at the other case, in cosine A equals negative 1/2, the angle A must be in quadrants 2 and quadrant 3. Now, cosine A is 1/2 whenever the angle A is pi over 3 in the first quadrant and 5 pi over 3 in the fourth quadrant. Remember, in the unit circle, our definition of cosine is the x-coordinate of the terminal point. So in this case, A is equal to pi over 3 and 5 pi over 3. Now for the second case, we're looking at angles in the second and third quadrant where the x-coordinate of the terminal point is negative 1. And this happens when the angle is 2 pi over 3. So A is equal to 2 pi over 3 in the second quadrant. And the other one is at the third quadrant, which is 4 pi over 3. Thus, the solutions of the given trigonometric equation are pi over 3, 5 pi over 3, 2 pi over 3, and 4 pi over 3. Next, next is, let's solve for tangent square z plus tangent z minus 2 is equal to 0. So observe again that this equation contains only a single trigonometric function, which is tangent of v. However, if we look at the form of the equation, it is tangent square plus another tangent minus a constant equals 0. So we can convert this into a quadratic equation by letting a dummy variable. Let's use variable m to represent tangent of v. So in this case, tangent square of v can be written as m squared, and then tangent of z can be written as m. So we write here plus m, and then we write minus 2 is equal to 0. So this equation is quadratic in the variable m. So in solving for quadratic equation, we can make use of factoring if the quadratic expression is factorable, or we can use quadratic formula if the quadratic equation is not factorable. But this one, we can factor this as m plus 2 times m minus 1 is equal to 0. By the zero product property, we can equate both factors to 0 and eventually solve for m. So in the first equation, m plus 2 equals 0, we transpose positive 2 to the right side, so we get m is equal to negative 2. For the other case, m minus 1 equals 0, we transpose negative 1 to the right side, and we get m is equal to 1. So since we have solved for m, we write it back to tangent of z because m is equal to tangent of z according to our representation. So the m here can be written as tangent of z is equal to negative 2. And for the other case, the m will also be replaced by tangent of z is equal to 1. Now on the definitions of the unit circle, tangent is equal to the y-coordinate over the x-coordinate. But if we try to divide all the y-coordinates here on the unit circle by the corresponding x-coordinates, none of them will be equal to negative 2. So negative 2 here is not a usual value of the special and quadrantal angles on the unit circle. So in order to solve this problem, now we can make use of the inverse tangent function. Now remember, tangent is negative in quadrants 2 and in quadrant 4. So if we try to solve for z, we make use of z is equal to the inverse tangent of negative 2. So using our calculators, make sure that the calculator is in the degree measurement. So we can make use of the inverse tangent of negative 2. And this gives us negative 63.43 degrees. But this z equals negative 63.43 degrees is an angle in quadrant 4. So in order to get the other angle in quadrant 2, we have to add 180 degrees. Because if your angle is in quadrant 4, no, uh, adding 180 degrees will give us an angle in quadrant 2. So in that case, z is equal to negative 63.43 plus 180 degrees, and that gives us 116.57 degrees, which is in quadrant 2. Now, for the other case, tangent z is equal to 1. This equation is solved if we use the angle pi over 4. Now, since this is positive here, tangent is positive in quadrants 1 and 3. The angle that will satisfy this equation is pi over 4 because the y-coordinate when divided by the x-coordinate will give us positive 1. And in quadrant 3, it's 5 pi over 4 because if we divide the y coordinate by the x coordinate, it will also give us positive 1. So the values of z are pi over 4 and 5 pi over 4. So the solutions of this equation are negative 63.43 degrees, 116.57 degrees, pi over 4, and 5 pi over 4. Okay, next. Next is we have 2 minus sine of b is equal to 2 cosine square of b. Now observe that this equation contains two trigonometric functions, namely sine b and cosine b. So in order to solve this equation, we need to make sure that our equation involves only a single trigonometric function. In order to do that, we have to make use of trigonometric identities. Now, we see that in the equation, there is cosine square b. Now, recall that during the definition of identities or the discussion of identities, we know that sine square of b added to cosine square of b is equal to 1. So this identity involves cosine square of b. And in this case, we can solve for it cosine square of b in order for us to replace cosine square b here. So if we transpose the sine square b to the right side, we get cosine square b is equal to 1 minus sine square b. And now, if we replace cosine square b by 1 minus sine square b, our equation will now contain only a single trigonometric function. Okay, so let's write it down. 2 minus sine b is equal to 2 times cosine square b will be replaced by 1 minus sine square b. And then distributing 2 to both of the terms inside 1 minus sine square b, we get 2 minus 2 sine square b. So now our equation contains only a single trigonometric function. So we shall transpose all the terms at the right side going to the left side, and we get 2 minus sine b. These are the terms at the left side. And then the terms that are transposed will now be written as negative 2 plus 2 sine square b, and then equals, the right side will now be 0. So combining like terms here, the positive 2 and the negative 2 will cancel out, and we get 2 sine square b minus sine of b is equal to 0. Now, this equation is in quadratic form. So we shall use factoring, and we can let m, a dummy variable m, to represent sine b. So our equation can now be written as 2m squared minus m equals 0. Factoring this, we can factor m, and the second factor will be 2m minus 1 equals 0. So we get m equals 0 by the zero product property, and then 2m minus 1 is also equated to 0. So now, since m is equal to sine of b, we write sine of b is equal to 0. And then we have 2 sine of b minus 1 equals 0. So let's solve first for sine b equals 0. So sine b equals 0 means that the angle b should have a terminal point having 0 as the y-coordinate. And in this case, the angle 0 degrees has the y-coordinate 0, and the angle pi has the y-coordinate 0. So this means that b is equal to 0 and also equal to pi. Now for the other equation, let's solve for sine of b. We transpose negative 1 to the other side. So we get 2 sine b is equal to positive 1. And then we divide both sides by 2. So this gives us sine b is equal to 1 half. Now observe that the value is positive and sine is positive in quadrants 1 and in quadrant number 2. And the angles having 1 half as y coordinate are pi over 6 and 5 pi over 6. So that means the angle B in quadrant 1 is pi over 6 and the angle B in quadrant 2 is 5 pi over 6. So the solutions to this particular equation are 0 comma pi, 0 and pi over 6 and 5 pi over 6. Okay. And then lastly, we have the equation 2 sine b minus cosecant of b is equal to 1. So observe here that the equation contains two trigonometric functions, which are sine b and cosecant of b. So again, the technique is to write one of the trigonometric functions in terms of the other trigonometric function in the equation. Now recall that the trig function sine b and cosecant b are reciprocals of each other. So that means cosecant of b can be written as 1 over sine of b. So this means that we can replace cosecant of b by 1 over sine of b. So this gives us 2 sine of b minus 1 over sine of b is equal to 1. Now, since there is a fraction in the equation, we can get rid of this fraction by multiplying both sides by the least common denominator, which is sine of b. So in the left side, we multiply sine b by 2 sine of b, and that gives us 2 sine square of b. And then we also multiply sine b to the negative 1 over sine b, and that gives us minus 1. And then at the right side, we multiply sine b by 1, and that gives us sine of b. Now the fraction is removed. Now observe that our equation contains only a single trigonometric function, which is sine of b. So now we can transpose sine of b to the left side, and we write 2 sine square of b minus sine of b minus 1 is equal to 0. So similar to the previous problems, we can write this as a quadratic equation. So if we let m be equal to sine of b, we can write this as 2m squared minus m minus 1 is equal to 0. So again, we can make use of factoring by writing this as 2m for one side and m for the other side, because 2m times m is 2m squared. And then we have minus 1 here and plus 1 here. So these are the factors, 2m plus 1 times m minus 1. So using the zero product property, we write 2m plus 1 equals 0. And then the other one is m minus 1 equals 0. And this gives us m is equal to negative 1 half. And for the other case, we have m is equal to positive 1. So if we write m back to sine b, we get sine of b is equal to negative 1 half. And then for the other case, we write sine of b is equal to positive 1. So in the first case, since Sine of B is negative 1/2, then we see that the angle B is in quadrants 3 and 4. And among the special angles here in the figure, um, the angle with y coordinate equal to negative 1/2 is 7 pi over 6 and 11 pi over 6. So that means B is equal to 7 pi over 6, and then the other one is 11 pi over 6. Now, for sine B equals 1, this is a quadrantal angle because pi over 2 has y coordinate equal to positive 1. So that means B is equal to pi over 2. So the solutions of this equation are 7 pi over 6, 11 pi over 6, and pi over 2. So these are our examples for solving trigonometric equations. And I hope that you learn on how to solve these types of equations. Thank you for listening.